I'll go ahead and start.
Go ahead.
Okay, good morning, everyone. This is the November and final monthly chapter, Penn York chapter monthly webinar training.
Muted.
This is Sean Stafford speaking, and our presenter today is going to be Steve Harris. Steve is the Senior Director of Technical Education at the SCTE. Now, before we get started, just a couple announcements. There is an attendance form under the handouts tab, which you can see on your screen. If you have more than one person attending the webinar today, then it's helpful for you to get credit for the training to make sure that we have a record of all who are in attendance, and that can be emailed to the email address showing on your screen, jshearer@metrocast.com. And you could also get Jeff's address at our website, pennyork.org. Just a brief note about SCTE Penn York chapter and certifications that we offer. Any of the people listed below are proctors and could assist you with your SCTE certification training questions or certification needs. And our presenter today is not Doug Swank, so apologies for that. Our presenter today is Stephen Harris with SCTE. If you have suggestions for future webinar topics, those suggestions can also be emailed to our VP of Education and Training, which is jeffshearer@metrocast.com. And I think without further delay, we'll go ahead and introduce Steve Harris. Steve is a subject matter expert and sought after speaker in the telecommunications and information technology industry. Steve develops engineering technical curriculum, adult learning content, industry certifications, career progression programs, operational practices, symposiums, webinars, and a host of other technical resources at the SCTE and the ISBE. He's responsible for industry networking and outreach, strategic business development, academy and corporate partnerships, instructor-led vendors, and instructional delivery across all disciplines. He has written a number of articles for industry trade magazines, moderated various technical panel discussions, and participates at ANGA in Europe, along with Hornados in South America. Prior to his current position, Steve was responsible for development of adult learning curriculum and customized technical content for regional and national markets at Comcast. At Comcast, Steve evaluated the effectiveness of training programs, provided experienced leadership for growing technical training initiatives, which led to his distinction of being the inaugural recipient of the SCTE ISBE Excellence in Cable Telecommunications Learning and Development Award. So without further delay, we'll be turning
Unmuted.
to Steve Harris, who's presenting to us today on the fiber deep architectures. Steve, go ahead, take it away.
Thank you so much, and I appreciate the introduction. Hopefully everybody can hear me, and I just want to do a quick sound check. Is my audio nice and clear?
You sound good to me, Steve.
Okay, just want to make sure in my screen, everybody can see my screen nice and well?
Yes, if anybody has any issues, please raise your hand.
I'm sorry, was that a yes?
It looks fine to me.
Okay, yeah, I just want to make sure everybody can hear me well and can see. So we're going to talk today about fiber deep, and I got to tell you before I dive into this, just spending some time with Comcast the last couple days, and spending time with Liberty Global and Charter and others, and heading to Rogers next week. I got to tell you that the rate of change in our industry is faster than ever before. The number of technologies coming down the pipeline is amazing, and being in the industry for almost 20 years. And prior to that, into the IT industry, all your Cisco and other certifications there, it's just that we are moving very, very fast. So I hope that once we get through this presentation, you'll have a sense of all the things that are going to happen and change. And if you think about, why this is happening, is this, the customer is really driving this need, and the technologies that are available to us is really driving this need. So without further ado, I'll jump in here. Today, I want to give you a little bit of an overview of the fiber market, what's going on in the industry before I dive into the fiber deep architecture. And then I'll also talk about a little bit about the MSO fiber upgrade plans. As technicians and installers and folks that work in the outside plant, head end and such, even the engineering folks, you personally need to be prepared for what's coming down the pipeline. And SCTE works very hard to make sure that you have everything you need to be successful in your career. But it's a lot of change, and it's actually very good change. It's going to set you up real nice for your career in the future. So I'm hoping that you'll really like everything I share with you. Why are we adding so much fiber? There's many reasons. I'll hit some of the highlights there. And then how is the network evolving? Because really the little bit of the history of the access network is going to show you the direction that MSOs are going over the next 5 to 10 years. And then we'll get into the fiber architectures. Fiber deep is one of those architectures, but there's a lot of tools that make up fiber deep, right? So we could talk about fiber deep and that's it, but that's not the whole story. That's only a piece of the story. So I'm going to share the whole story, okay? And I see some comments coming in. Hopefully they're not for me. Okay. We'll talk about the optics. So with fiber deep, the optics are going to change. I don't know if you've heard of coherent optics, but that's something new that's coming down the pipeline. I'm sure you heard of digital optics. But we'll talk about the difference between analog, digital, and coherent optics, because that's also part of the story. We're also going to be working on spectrum during our fiber deep deployments. So we'll talk about what does that mean when it comes to fiber deep, a little bit about the challenges, and then we'll open it up for Q&A. Now I hope I'm not opposed. Any questions you have along the way, please just enter them into the chat window. I'm perfectly fine answering questions along the way. I know that waiting to the end, perhaps you kind of checked out. If you wait to the end, you're like, well, I had a question earlier on, Steve, and I forgot what it was. Let's just ask those questions as we go along. Let's make it interactive. Please feel free to participate with me as I go along, okay? So I just want to open up a little bit about the market, what you guys can expect. And I think this story everybody knows, right? Here's some of the top US broadband speeds. We know that they keep rising. We know that we're all gigabit. You can see everybody here from our competitors, Google and AT&T, CenturyLink, offering gig services. But we can also see the operators like Cox and Mediacom, Cable One, and many others on the list here also working with gig service. You can see down here at Charter and Atlantic Broadband, both of these companies have a strategy for 2018 around DOCSIS 3.1, around fiber, more fiber in the network, fiber deep scenarios that are going to push 1 gig. You can see Comcast at the top has a 2 gig offering, but it's clear that the speeds keep rising, and this is the demand of our customers. If the customer can get 1 gig for the same price as 500 megs, why not? I always use the analogy, if I'm in the Costco and I can get 1,000 rolls of paper towels for the same price as 500 rolls, why not buy the bigger? So it's more is better, and that's kind of the mentality of the customer. They see that, oh, it's a 1 gig service, that's better than one I have as a half gig service or 100 meg service. If somebody offered 2 gigs, they would take that. If they offered 5, they would take that, and 10, and so forth and so on, right? But that's clearly the story there. The size of the fiber market growth, you can kind of see down here at the bottom, starting in September 2001, we're down here as far as homes marketed and homes connected when it comes to fiber. Clearly you can see the trend going way up here as far as the number of homes marketed to, but you can also see the trend of the number of homes connected via fiber, right? So there's no question that this is going to continue to rise. And I have some other numbers I'll share with you up to 2017. But it's just 13 million homes here as of 2016 with this data from Fiber Broadband Association, and it's going to continue to grow, no question. Also on the commercial side, the commercial buildings are getting more fiber. We can see in 2004 on the left-hand side, so you see that? Here's the fiber gap, huge, right? But now we can see as of 2016 from Vertical Systems here that the fiber gap is closing, that more and more businesses are getting fiber. And cable is a huge part of that. We have commercial and business services. We are seeing the smart office emerge. We're seeing more IoT emerge. We're seeing a ton of wireless technology, whether that's Wi-Fi, mobility, low-powered protocols, ZigBee, LoRa. But it's clear that the penetration of fiber is just growing from the residential side as well as the business side. From the cable MSO space, what are the cable operators doing? And I just picked the 5 largest operators operating out of the United States. But I could clearly tell a story and paint a story, whether it's South America with all the GPON work that's happening. And I'll share a little bit about the European story. Even in Asia as well, lots of GPON, lots of PON technologies. It's global. It's not just happening here. In some sense, I would say that we may be a little bit slower than other folks that are out there on the planet. But the clear thing is, whether we take a look at Comcast, and I just picked, like I said, the larger operators, aims to spend billions on the fiber deep program over the next 4 to 5 years. So it's a clear thing, as far as where is your career going to go in the next 4 to 5 years, it's going to have fiber in it, right? And what we're doing with the fiber deep program, and you'll hear it from me as I go through, is we're eliminating active devices in the networks like amplifiers. And the reason we're doing that is for the quality of experience for the customer, but really improving the reliability of the network. There's back in the day, we could have, remember those days where you had snow in your picture and you had an analog video and you saw the snow, and that became normal. As a kid, I grew up and I saw, there was some snow in my picture, but I watched it anyway, and it was normal. We moved from analog to a digital world, and those pictures now are either there or not there. And if they're fading away, they macro block, and that's just no longer acceptable to our customers today. So there has to be ways for us to make the network extremely reliable, and that's just on the video side, but take the voice side, take the internet side. All these pieces have to be 99.99959 of reliability. With the Fiber Deep program at Comcast, over 1 million additional optical nodes will be added to the network. So that's substantial. So the clear thing is that if you're working on amplifiers today, most likely tomorrow you'll be working on optical nodes. And these optical nodes are going to be much different than what you've seen today, and I'll share that with you coming up. Charter also has plans to add 2 million more homes passed over the next 5 years with fiber, or about 400,000 homes a year. All new greenfield homes, fiber to the home is coming. They expect fiber to the home to be 10% of the MSO's footprint in the next 10 years. But all the normal things that you do with fiber deep, reducing node sizes, improving service groups, those types of activities will be happening at Charter. Cox, they're going to overhaul their entire HFC access network in the next decade. And that's the same story, right? Adding more fiber, deploying more nodes, more fiber deep nodes, pushing fiber closer to the customer, and improving the reliability of the network, right? So that's clear on what the operators are doing. And the story continues. We've heard from Altice upgrade almost its entire U.S. footprint to fiber to the home or fiber to the X by the end of 2022. They talk about a project called Generation Gigaspeed, where they'll have 8 million homes passed, and that includes all of the New York footprint in Optium and most of the Suddenlink. But you can kind of see that the trend's going to continue. They're spending billions to improve the network. And the story continues with Liberty Global, one of the largest operators, and Liberty has offices in Denver. Most people think of Liberty Global as outside the U.S., but folks, if you read the news, that Liberty Global has a hand in a lot of different operations around the planet, including the recent acquisition of GCI in Alaska and portions of other operators in the U.S. But it's clear, they're in South America, they're in Europe as well, and they plan additional 5.6 to 6.3 million homes in its territories. Here, just as third bullet here, 1.4 to 1.6 million new homes slated this year, and a heavy spending on fiber deep program. So it's really clear as what the operators are doing. The percent key challenges for fiber deep or fiber to the home, and bear with me as I talk through this. When I say fiber to the home, fiber deep is a gateway to fiber to the home. So when we talk about fiber deep, that is a architecture that is a evolution to the HFC that's going to get us to fiber to the X deployments. So they go hand in hand. It's not that we're going to deploy a fiber deep architecture, we walk away, we're done. It's a first step. I was with Comcast yesterday. They're already talking about XPON networks like EPON being one of the bigger projects in the future. And we know that RFOG, radio frequency over glass, is already a big project for many MSOs. But you can kind of see the breakdown of some of the key challenges. And why do I share this with you? Because labor and installation are one of those challenges. So that's really for all the folks listening to me right now, getting up to speed and understanding more about the fiber technologies and how is that different than what you're doing today. So I'm giving you fair warning that your skills are going to need to be upgraded, and that's a good thing. As many of the operators have progression programs, and those progression programs are allow you to move into new positions, making better money than you are today. There are other costs that operators will spend. You can see actives and passives. There are additional nodes that will be added to the network, and of course the engineering side. But the good thing for us is for labor and installation, there's huge opportunity. And I put this together, and this is, again, this reiterate, here's where we were in 2010 right here in the middle as far as speeds go. Yeah, 30 megs. Yeah, we were pretty happy, you know, if we got 30 or 50 megs, and some operators might even had 100 meg service at the time, but we were pretty happy. But no longer that's the case. So here, as we're moving into 2018 right here, we're moving into that 1 gig space. And some operators have leveraged DOCSIS 3.0 to make that happen. Other operators may have leveraged some fiber to the home in some pockets. But the clear thing that's happening is this is going to continue to trend. At Expo, at Cable Tech Expo this year, we had 98 speakers this year, but all the speakers have very similar diagrams than what I'm showing you here, that we're going to continue growth of broadband speeds and capacity, and it's not going to slow down. So what I'm showing you here is, yeah, okay, DOCSIS 3.1, 10 gig, amazing stuff, right? 10 gig over DOCSIS 3.1 is amazing, but there's no stopping. You know, with coherent optics, we're going into the terabytes and terabits per second. So that's a whole new frontier. And you might say, well, that's Steve, that's so far away. That might only be 5 years away. And people are already planning on moving 100 gig and then beyond off the chart. So, and again, part of it could be staying competitive, but the demand, think of those larger businesses and what they need to compete in the marketplace. So hopefully I kind of set the stage on where we're headed as an industry. Feel free to jump in with any questions. So if you have any questions, just hit me up in the chat window as we go along. I'm going to talk about the access network evolution. I just want to kind of set the stage. Got some pretty detailed diagrams that I put together for you. But think about the early 2000s where we were. We were maybe one DOCSIS downstream channel, right? And then one DOCSIS upstream channel. But at the time, we were using 256 QAM and QPSK. And some of you in the audience might say, I don't even remember QPSK. What are you talking about, Steve? When I started, that was a big deal. But today, you hear talks of 4096 QAM, 1024 QAM. It's a much different story. A 6 megahertz channel with DOCSIS 3.0 is no longer required. We can bond many of those channels together to get to 192 megahertz. So it's a much different story. So what I have typically on my diagrams that as I go through is on the left-hand side, I have my OSS, my operational support system, which is everything needed to support the network, right? So that's your network operation folks. That's all those servers in the back there for provisioning, and then your backbone that ties everything together, right? And then we have some of the edge QAMs here that are used for video. Here's your voice, class 5 switch, and here's your CMTS. That's like my typical simplified back office area. And all those services get combined, and then they go over transmitters here in the middle. And when we mux everything together, a technology called wave division multiplexing, which you might have heard of. And our networks today, in the sense of they're just HFC based, are probably using a 1310 wavelength down and a 1550 wavelength back and forth to the node. The key thing here in this area is this is analog today. This is analog intensity modulation. And that is a barrier for operators delivering those next generation services. We're delivering DOCSIS frames. I only have 3 amplifiers here, but at the time we had much more than 3 amplifiers. And we were delivering DOCSIS services. Life was good. We perhaps had 1,000 to 1,500 homes passed on the node here, right? And we were living in a 700 megahertz world. We then extended that as we moved into the late 2000s. Some of us extended out to an 860 megahertz system. We improved the service group size. We improved the network size to 500, maybe 600 homes passed, and that could vary. We started increasing the number of downstream channels. We started increasing the number of upstream channels. So we started doing a surgical approach to the network to improve bandwidth speeds to the customer. But also we're delivering more and more video content and more services, right? We continue on in 2010. Now we're up to 4 DOCSIS downstream channels. But the thing here is we're adding more channels, trying to increase the capacity for the customer. And this was great as we're moving down. In 2012, we continue down. Now we're talking 8, 16, 32 DOCSIS downstream channels over 256 QAM. Like, how could it get any better, Steve? This is the best of the best, right? And then we increase maybe to 2 to 4 DOCSIS upstream. Notice that my DOCSIS upstream channels went from 3.2 to 6.4 megahertz. My modulation, the higher the modulation order, the more bits that you could send, the faster the upstream, right? So in the beginning, we used QPSK, which is great for noise, but not so much on the bandwidth side and the upstream speeds that our customers want. We moved from a QPSK to a 16 QAM, which offered better upstream speeds, but 64 QAM is even better. And folks are already talking about 256 QAM and beyond in the upstream. So anybody who's been with the organization for quite some time, you're probably sitting there shaking your head like, wow, things have really, really changed. The big note here, though, as we moved into 2012, 2013-ish, and maybe 14 for others, is there's not enough fiber. So this is another constraint. What we've been doing is using the fiber for business services, node splits, and we've been using it for backhaul services. So we're at a reflection point here. What do we do next? How do we extend these networks for the future and take it to the next stage, right? And again, as I go into next evolution, any questions that you have. So here we are in the next evolution is more fiber. So why fiber? And you may ask yourself, well, today operators are using it already. They're already using it to deliver their services over the network without any issues. And it delivers the triple play service and beyond. And it's attractive, right? In my neighborhood, competitors told me that if I got fiber to my home, that my home was worth more. And I don't know if you heard that yourself, but there's been some marketing that if I have fiber optics all the way to the side of the house, then my house is more marketable and I could sell it for more. Whether that's true or not, I don't know. I'm not selling my house anytime soon. But there's perception, and everyone in this room, there's perception that fiber is better. I don't think there's any question about that. If you talk to any of your customers, if you have any types of conversations, and even in your minds, you have a perception that fiber is better and more valuable. And we can use fiber to deliver all our current services, which is great. We know that it offers higher bandwidth, so that's another reason. And why do we need some higher bandwidth? Well, obviously 4K, there are operators that just announced that you can actually consume 4K over Netflix. So there's operators that have embedded Netflix into their cable boxes. And with my service here at my house, I can actually consume 4K, and not just regular 4K, I'm talking HDR, high dynamic range 4K. And this is the next generation of television and a video experience that operators are delivering because the customers want that. And we also see increased content options, so more and more content and more over-the-top options. So these are all driving that. And then some of the folks sitting out there, think about gaming, think about virtual reality, augmented reality, artificial intelligence. These are things that are on the horizon. I had a chance to be at CES, Consumer Electronics Show last year, and one of the biggest topics was virtual reality. And I had a chance to experience it. And if you had a chance to experience it with a real experience, it is amazing. You feel like you're there. You're participating, whether you're watching a movie or gaming experience. This is just going to catch on and grow. And the other piece I'll share there around the bandwidth, I have a 13-year-old at home. We have converted her, what we used to call a playroom, into a smart room. She's got at least a dozen connectivity devices. And this is the world she lives in, right? So this is, we think about it, hyper-connected kid who has 12 pieces of 12 devices that are connected on a wireless experience. And if you think about your home, the same thing. I'm sure you have more than 4 devices in your house that are connected. So this is another reason. And obviously the energy piece of it. The 3 P's for operators, the 3 main costs of operators, I don't know if anyone knows those costs, but think to yourself, what are they? Well, people like yourself in the room, you're one of the major costs for an operator, right? The next one is programming, and everybody would agree with that, right? Programming is very, very expensive, especially that video content. Operators spend billions of dollars per year. And the third one is power. We spend a lot of money on power, so it's a huge focus area for us. So if we can find out or find ways to lessen the power in our head ends and hub sites and lessen the power in our access networks and save money, that's a win for us. So that optimizes our operational expenses, but also that it also operationalizes and reduces our capital expenditures. So it's a savings for the operator in the long term. So no power required for active devices, and the devices for like an RFOG network, they're powered at the side of the house. So when you install a RONU, an RFOG optical network unit at the side of a customer's home for a fiber experience, the power is supplied by the customer and not by the operator. So we don't need to have all those power supplies in the network and all those active devices. So that saves us a lot of money. And I told you I'd give you more of a updated statistic here. There's 25% of homes today that are connected, more than 15 million. So it's growing, and that's just from 2016, where I was showing you about 13 million. And most people offer 100 meg service today, but I showed you that we're going into a much faster service. And 100 gig was, you wouldn't even think of that. I remember back in the day, I'm not going to date myself, but back in the day, I worked at the Radio Shack, and I was happy with my first Tandy 1000 computer, which had a 1200 baud modem. So that was dial up. It wasn't even a 56K dial up. So you're probably like, wow, this guy's older than dirt on the phone. But to actually think of a 1 gig service at the time, or even even be talking about a 100 gig service is crazy. The fiber future-proofs the network, meaning if your operator today is installing an RFOG service, we can actually do an overlay off that RFOG service. Meaning, when you install the RONU, the RFOG radio frequency over glass ONU optical network unit at the side of the home, there's a pass-through port available. And if your operator bought that model, you're able to connect an additional fiber to that device and then drop in Ethernet passive optical network in the home, or drop in gigabit passive optical network in the home. So you don't have to remove the RFOG solution to offer the next gen EPON or GPON service. So that's what we talk about future-proof. And even at the head end and hub site, we drop in an OLT, an optical line terminal, and then with that, we're able to offer the EPON and GPON services. And you might say to yourself, whoa, Steve, how are we going to do that, and what's going to happen to the provisioning? Well, hold on, I'll tell you all about that. That's coming up. And obviously the knowledge and skills. The folks that are doing fiber, when I was with Comcast, the folks that were doing fiber were making more money than the folks that were doing coax. So when I was there, and I believe that's still the case today. So it's a good skill to have. It's something that you want to work towards, and it's where we're going. It's where we're headed. And I think I hit most of the services, but we hit the 4K and the virtual reality. Obviously, these are services that our customers want. You laugh and you say, "Well, 8K? What are you, crazy?" I've seen 8K, and 8K is reality. There is demos. When I was at the Consumer Electronics Show, they had 8K experiences. So that could be something that comes down the road. You can see the resolution there. Voice reliability, HD voice. More and more people are. I'll give you an example. The TV could go out, the phone could go out here at the house where I live, but if the internet goes out, I have a 13-year-older that's right at my desk. Daddy, what happened? The internet's out. But the TV could be out for a month. We wouldn't even know. So you think about that for a young one, mission critical. I don't know if it's mission critical, but a lot of people rely on the internet for their day-to-day, right? So it's more of how we rely on things. But just think about fiber deep and what it offers outside the home. So if you think about this whole IoT, and we talked a little bit about Wildwood, New Jersey, for instance, where all their parking meters are over a protocol called LoRa. It's a low-powered protocol. And this gives the ability to somebody with a smartphone to go in and see which spots are open when they actually go into this town. So if you think about it, you can now link things and experiences outside over this fiber deep network. So it's not just the residential customer, the business customer. Think outside of that. Think about parking meters. Think about traffic patterns. Think about airports and just all types of different opportunities that exist by operators moving into this. Think about mobility of the future. Think about wireless hotspots. So that's the next gen wireless. And then obviously IoT. If your home's not connected with IoT products, I think it's something that more and more people are considering. The fact that you can just walk up to your door and it reads your phone and Bluetooth kicks the lock and you come walking right in the house, or you can set rules where your lights go on or your thermostat. This is reality. This is the places that people want to or experiences people want to have. So that's happening more and more. And the scary thing is that people start relying on this, right? And when this stuff doesn't work, if I forget my phone, it's like, wow, I can't get in the house now. Before it was a key. And the reality for fiber deep, it is less expensive right now than a fiber to the X experience, like a fiber to the home or fiber to the prem experience. And that's okay, because we can still deploy the fiber deep. We could still leverage our DOCSIS networks. We could still leverage the coax last mile, leverage all the CPE in the home, and the whole entire back office. This is a stepping stone. And then once we get those fiber deep networks out there, then we can leverage them to offer the fiber to the home and fiber to the prem and fiber to the business and curb and other things. And of course, the last, the thing is better for DOCSIS, right? If you're familiar with DOCSIS and how it operates today, you know that DOCSIS uses 256 QAM, and I showed you that. Well, the DOCSIS of tomorrow leverages 1024, 4096, and 16,384 QAM. And you know that the networks today support frequency division multiplexing in the forward path or the downstream. The networks of tomorrow are OFDM, orthogonal frequency division multiple access, or multiplexing rather. In the upstream, they're OFDMA, orthogonal frequency division multiple access. So these are better for DOCSIS. You need a cleaner network, more reliable network to run those. So just doing a sound check. Everybody can hear me okay? Just want to make sure that my audio is not going in and out and everything's okay. Anybody still out there? Yeah. Okay. Yeah, Scott said he's here. Good deal. So the access networks compared. So I'm going to get into what's next, right? So let's take a look at what we're getting into. Today we have optics that are analog. You say it's a big deal. What's the big deal? It doesn't make any sense to change anything. Well, fiber deep is going to give us a digital optics. Analog in some cases, digital, analog and then digital in some cases, and then digital in the upstream. So these are things that operators want and reasons why we're doing the fiber deep, right? We need power for the amplifiers and line extenders. We don't need line extenders. We don't need amplifiers in the fiber deep. So I don't have to worry about pads and EQs and all these good things in the amplifiers. Those things go away, and I just focus on splicing coax and taps. The distance for HFC optics is typically shorter. We can go very long with the optics within 1,000 feet, and in some cases a few hundred feet within the home. We can do distributed access architecture, which is not common. I'll describe what that is, but it's more common in the fiber deep scenario. And typically the HFC today uses a centralized access architecture. And really what that means, CMTS is in the head end. The physical and the media access control portions of the CMTS sit in the head end. We're talking today about taking the physical portions of the CMTS, the physical portions of your edge QAMs that do video, and moving that into the access network, moving that into the fiber deep network. You say, what? That's crazy. It's called CCAP, right? And you might have heard that one, and we'll talk about that. And there's also talk about the reality of virtual CCAP, where you take the entire CMTS and your edge QAM, and the CMTS that does your voice and data, and the edge QAM that does your video, and virtualize the whole entire thing. So virtualize, like, whoa. And it's already becoming, there's already people working on this and being tested. Now, we're QAM-based today in the HFC, which is great, but we know that IPTV is where the future is. So this it provides a QAM solution for operators, an IP-based solution for operators. That's great. We know the service areas could be larger. The number of homes passed could be larger. And then we can go smaller and smaller with the segmentation, maybe 128 homes or less. And today we support DOCSIS, so we don't support both DOCSIS and fiber to the home. But in the fiber deep network, we can do both. Okay? So there's lots of advantages going fiber deep for operators. So what's next? So what I want to do is kind of walk you through a couple architectures, because as I talk about fiber deep, this all happens. These all come together, and it's kind of hard to say, well, we're just going to do fiber deep, we're done. All these pieces happen. So let's start off with the first piece that's already happening. And you might say, yeah, I know we have this. It's called CCAP. And down here I have the acronym for you. It's one that you want to know. It's called Converged Cable Access Platform. Basically, take your CMTS, cable modem termination system, take your edge QAM, and it's one device. So it does your video, your voice, and data. Because voice would happen at the class 5 switch that connects to the CCAP core, and then out to the customer. The reason operators are doing this, one is to save space, right? So I can save space, I can save power, I can make the head-end hub site, I can make it more of a critical facility by using less space in the location and more efficient, right? But the big piece is this: you can actually pull pieces of it and put it out here in the field in the access network. You say, whoa, what's going on? What I'm saying is that the node of the future could be more than just an optical to coax conversion. It could be what we call a remote PHY device. It could be the physical portion of the CCAP core is now located in the access network. And you say, that's crazy. That's crazy. Now it's already happening. It's already happening. And it's going to happen more. We had a seminar on the pre-day of Expo this year, a couple weeks ago, maybe almost a month ago. And we expected 170 people to show up to talk about this. Over 400 people showed up, standing room only. This is how popular this topic is. So think about, 400 engineers from all different operations all across the planet, VP level and senior directors of engineering, all there because this is a hot topic. And the reason why is this. We can take the DOCSIS MPEG's your video, moving picture experts group, and your out-of-band channels, that's your out-of-band signals for your cable boxes, right? And we can move that all into the field, and we can free up space in the head end. What do we get in return for that? Is we can go a great distance with this connection, this fiber connection, all the way in the access network, right? But we get the digital pieces. So now we have digital fiber. You say, well, I don't really know what that is, Steve, but you're going to tell us, right? Yes, I will. Then, if you have digital fiber, then you can run Ethernet connections for businesses. I can run Ethernet connections all the way to your home. And I can emulate that. I can do an emulation of PON. It's called pseudo-wire. So pseudo-wire logic basically allows me to emulate PON connections and Ethernet connections. So this is one thing that's happening, right? We call it distributed access architecture. And you could do this in your HFC. You don't have to have fiber deep, but this is, people are going to deploy fiber deep, and then they're going to add this on top of it. So you're going to use both of these as a tool. So there might be scenarios where it's just fiber deep, and then there's going to be scenarios where it's fiber deep plus this. And I'll show you how it works together. The first piece that we're doing is just taking the physical components, your QAM, your multiplexing and modulation, your frequency division multiplexing, your OFDM, your QAM, and moving that out into the field, right? Because you have the ability to take more of the CMTS, called a MAC-PHY, Media Access Control, take more of your CMTS, put it in the field, and then you have the option to take a little bit of the MAC portion and leave a little bit at both locations. The rest of the network is still your amplifier. So we haven't solved for the amplifier piece yet. What will this do to the size of the node? Well, this particular technology, this could reduce the node. So depending on how many RFI devices, how many of these devices you put in the network, it's just like anything else. So you could replace what you have today, and say if you have 500 homes passed today, you can replace that with an RFI device node of 500 homes. Typically, when doing this technology, you'll do it in a scenario where you're doing a node split. So you can actually reduce the number of homes passed by this technology. Oh, the physical size of the node. Okay, Mike, thank you. Yeah, so the physical side, I'll show it to you. It's not much larger than your regular node size. So I'll show you some pictures of the fiber deep nodes that have all kinds of components in them. So it's not much larger. So you don't have to worry about this huge box on the pole. So yeah, good point. But I'll show you what it looks like. I have a picture coming up. So this is what you've been waiting for, fiber deep. Yeah. So just trying to show you that because both of those kind of come hand in hand. But here's the network we've been talking about. Still have that combiner. So all this stuff above is what we already talked about. This is the same network, right? There's that CCAP piece. So depending on which scenario that you use, the CCAP still talks to the back office, so that's still there. All these signals get combined together, and operators can choose to use dense wave division multiplexing. You don't have to use dense. You could just use wave division multiplexing. And what happens here, depending on the scenario you use, the top or the bottom, you have a muxed fiber right here that goes out to a multiplexing point. Now, some operators might call that a mother node, right? The multiplexing point could be a fiber enclosure. I'll show you, that's coming up. The multiplexing point could be a node housing that we just talked about. So it could look like a node. Depends on the scenario. Because depending on the distance of this fiber, if it's a long haul fiber, we might need a EDFA, erbium doped fiber amplifier, at the multiplexing point. So there's scenarios where you have a multiplexing point that does not need power, right? So all you're doing at the multiplexing point is recovering the fibers and delivering them downstream to fiber deep nodes. There are scenarios where you might have a multiplexing point that needs power because you're going to put an erbium doped fiber amplifier there so you can go really, really far, really long distances. Maybe you want to go to 160 kilometers instead of 80 kilometers or 40 kilometers. I'll show you some of those examples as well. So what we do at the multiplexing point in this example, all we do is if we mux 16 fibers together or 32 fibers together, we're going to pull off those wavelengths and then deliver them to fiber deep nodes. And then from the fiber deep node over coax to your tap to your customer. No amplifiers, no line extenders. And like I said, down here is that EDFA is optional. And if you do have an EDFA there, we'll need to have power. So typically in this scenario, if we did 16, we mux 16 together, then we would deliver this to 16 fiber deep nodes. Those distances will depend on a couple scenarios, which I'll share with you. So once you have, and all we're doing, and now we're about 1,000 feet to the customer, right? Maybe in some cases a few hundred feet. But what we have here is increased reliability. It's all over glass. We don't have to worry about those RF distortions and those pieces. We're going to have better signal to noise. The signal to noise and the MER, modulation error ratio, is going to be very similar to what you see at the head end. We're going to have beautiful metrics in the access network, which we're all trying to achieve. And if we can have better metrics in the access network, what kind of modems do you think we can put here? DOCSIS 3.1, 1024 QAM, 4096 QAM. We can run that OFDMA. Then we could talk about symmetrical DOCSIS, which is the next one coming. So that's the fiber deep. Not as complex as what I just showed you. Once you have the fiber deep scenario, which I'll show you next, is that I can take this fiber deep node and I can put modules into this fiber deep node where I can deliver fiber to the home right here. Kind of hard to draw, but I can do fiber to the home scenario. So that sets me up in the future. So if I want to drop in take and do fiber to the home with different wavelengths, I could. And I could use an optical splitter, change this all to fiber, change this out to a optical tap, and drop a splitter in, and I can split out to 16, 32, 64, 128 homes and do fiber to the home, which is great. And that's also strand mounted. So that's my next one, fiber to the X scenarios. So now that I have fiber deep out there, this sets us up for what we call fiber to the X. And the X it could be curb. We could do, bring stuff from that fiber deep node and then take it all the way to the curb of the customer. We could take it and drop in a scenario where the fiber deep node becomes a virtual hub, and that virtual hub goes right into an MDU when we drop a distribution cabinet in. It's very, very flexible. Of course, you got fiber to the business, but the same thing here. You could take that fiber deep node, it becomes a virtual hub, and now you can drop in a cabinet in the bottom of the business and service the entire building because you have fiber deep. And the same thing here. Here's your fiber to the home and fiber to the prem. But it sets us up for all types of scenarios. And again, off the fiber deep. Once you have your fiber to the home, you have your fiber to the business, fiber to the MDU, whatever it is, now it sets you up for this scenario. The top portion, all this top portion here, that's our HFC. So there's nothing new there. Here's what it sets it up down here. So once you have a fiber deep network, then I can start doing RFOG. This is radio frequency over glass, SCTE 174. You can download it and read it all about it today. No problem. It's on our website. So we're still, the nice thing about RFOG is you're doing fiber all the way to the house, and operators are doing that. And this is the next stage. So I get fiber deep out there. Now I can start doing fiber to the X, and I might choose to do RFOG first. Now I have RFOG all the way to the home. You say, why RFOG, Steve? The reason is, still have the DOCSIS frames. The reason is, you still have your back office, nothing changes. And all the CPE in the home, the same. So you don't have to rewire the house. You do not, and you're going to have beautiful metrics at the house. You don't have to change the equipment out in the home. You'll say, well, how fast is RFOG, Steve? It's as fast as the DOCSIS modem you drop in the house. So if you drop in a DOCSIS 3.1 modem, 1 gig modem, then you have 1 gig service over RFOG. The same cable boxes work. So everything's the same. So it's another incremental step. The nice thing about this, there's a pass-through port. You come back tomorrow and you put EPON in here. We could drop EPON in. The next step. So it's stepping stones instead of saying, well, I'm going to just build out fiber to the home all the way to everybody's house. I'm giving you the 5 to 10 year evolution here. So it's not something that's going to happen tomorrow, right? But that's the nice thing about RFOG. So then the other scenario with RFOG is the EDFA in the field, which I showed you. So this fiber deep node now becomes a V-hub, a virtual hub, has an EDFA in there, and still does fiber deep for those fiber deep customers that want to do coax. But you also have the flexibility of delivering your RFOG. This scenario, notice that you get 60 kilometers plus a 20. In the previous one, 10 to 20 kilometers. So we go a lot further. And we're not done yet. Let's go get more complicated, right? Let's keep going. Again, the whole top portion is your HFC. Nothing there. But down here, we start adding in this stuff. Operators now can add an optical line terminal. So you still have your CMTS, you still have all your other goodies back here. If you have CCAP, you still have that. It's all there. But now you're going to add EPON. And yes, Comcast said EPON, EPON, EPON. They're RFOG, RFOG, RFOG. And that's just one person. But we can go to another operator that says GPON, GPON, GPON. The nice thing about the OLT, it does both. So if you want to do GPON off your OLT, you can. If you want to do EPON, you can. It depends on what is the vision for your future business. Do you want to offer Ethernet services? You could do GPON services that also offer Ethernet services, because they use a protocol called GEM. I think it's called Generic Encapsulation Method. You can check that if you want. But it gives you more flexibility, right? So here's that RONU for RFOG. Boom, you pop off of that, put your ONU in for EPON, and now you got 10 gig at the MDU. This is great. You could have a cabinet that's fed from a fiber deep node. You could have a strand mount that I was showing you, but you now have the flexibility to do Ethernet and DOCSIS over your access network. Back here, you say, well, all right, see, that's great. You put this new box in, is this going to be a problem? It uses DOCSIS provisioning of EPON. So your NOC, ROC, SOC, whatever you call them, they are still working with modems, virtual modems. That's the V cable modem. So when they actually look at the health of devices, this virtual cable modem maps over to an ONU in the field. So it makes the ONU look like a cable modem. So it's very easy for your staff to transition over and monitor the next generation of services. It has a DOCSIS mediation layer that allows you to use your entire back office for EPON. Beautiful, right? And so, well, Steve, what about GPON? We had Cable Labs came up with the specification for DPoE. You can go to their website and download it. They also came up with a specification for DPoG. You can go right to their website and download their specification for that. So go cablelabs.com. So it makes it a lot very nice. So that's what we're looking for. How do we leverage that? Now, once you go into the home, you don't need to have cable modems. I don't know why I have a cable modem there off ONU. I might have forgot to take it out. Because the ONU, the optical network unit, is the cable modem. Then you can deliver IPTV. So you have IPTV out there. You know, we have a cable modem here because that's coming off an RFOG device. There's no reason to have a cable modem there. And you can do 1 gig, 10 gig, depending on what wavelengths that you're using. But you can see that 1490 and 1310 nanometers is your EPON. Your 1577, 1270 is your GPON. You can see that 1610 and 1550 are your wavelengths for RFOG. Yes, they all can operate over the same fiber at the same time. Beautiful thing. The fiber distribution cabinet is your splitters, your couplers, your parking lot. So everything that you need there. And yes, there is technology to come over to overcome optical beat interference of RFOG. We have a beautiful class that covers all this. I'm just giving you the highlight reel. So now you have the whole story. So it's fiber deep is not just a is not just the end solution. A lot of people say, oh, it's fiber deep. Okay, we're done. I'm giving you the whole story. This is the whole story. Here's how it all starts. Fiber deep is the first step, and then it's fiber to the X. Then it's going to be RFOG perhaps or EPON. And this is just a summary slide. Kind of hard to see, I'm sure, but you can see all the different wavelengths that are being used, all the different video options. So I'll just pull out EPON because that's been the real popular one down here, the EPON. These are IEEE standards. You can go right to IEEE.org and download the AH and AV standards. They do charge a small fee for that. You can see the distance. You can see the split options. You can see the speeds. It uses Ethernet and IP and the wavelengths. That's coming. And of course, GPON, you're not going to use PON. You're not going to use APON or BPON. You're going to use GPON or next generation GPON. These are these here. They use GEM. You're like, well, Steve, GEM, that's not going to help us. We want Ethernet. They can emulate Ethernet. And actually, the header on GPON is actually a little bit cleaner than the Ethernet header found in EPON. It's simplified. So there's RFOG down the bottom. You can go to our website, download that, not a problem. And the speeds are all DOCSIS based. And we can still do QAM. And there are your wavelengths. Okay. So let's talk about fiber deep. I don't see any questions there. Feel free to jump in with questions. So fiber deep. So the rest of my talk is going to be really focused on more about fiber deep. I gave you the whole story, how it all fits together. So let's talk about fiber deep. Node plus zero. That's another name for the same thing, right? So the idea is we drop in the fiber deep node plus zero. There's no amplifiers. There is no line extenders. We talked about that. It's in the last mile, so we can leverage all this last mile area because this is expensive. It's expensive to send out a construction company and just rip everything out and update it, right? So we're able to leverage that last few hundred to 1,000 feet from the subscriber without going in and spending a ton on construction. And we can do that in incremental steps. We can overbuild it with fiber later on. We can, in some cases, shorten the coax runs. So if the coax is maybe 25 years old or 20 years old, we might consider shortening those runs to get better service, right? The Fiber Deep delivers all the current services we talked about. Cloud-based services, enabling fiber and DOCSIS-based business services. We talked about that, right? Fiber Deep leverages an operator's high-capacity coax last mile. I think I already said that. Why is that in there again? All the CPE, set-top boxes, EMTAs, EDVAs. If you use EDVAs, that's the embedded digital voice adapters that support IMS and SIP. God, one acronym after another, right? IMS and SIP is IP Multimedia Subsystem, and SIP is Session Initialization Protocol, but it's a better way to do voice over IP, and some operators might use those instead of EMTAs. But the clear thing is you use boxes, cable boxes and cable modems. Everything can be leveraged the way it is today. We can leverage all the interior wiring of the customer, so it's a great thing. Single touch approach. The idea here is let's not keep rebuilding the HFC or access network over and over again every time a new technology comes out. So by putting Fiber Deep in, what I tried to show you is I can very easily go back to the Fiber Deep node and then add a module in there for, say, Remote PHY. Add a module in there to do to do an EDFA if I needed to go longer distance with fiber. And an EDFA is just nothing more than a fiber amplifier. Or I wanted to do fiber to the home. I can keep updating the Fiber Deep node without rewiring, redoing a whole bunch of construction onto my network. And then we talked about this, OpEx and CapEx. And the big thing is quality of experience. We know that customer focus is the most important thing for operators. So the enhances the quality of experience. And I don't want to think about my cable operator, right? I'm in the cable business, but quite frankly, I came home the other night and my modem stopped working, and it was chaos in the house, right? And what all that happened, it was put in wall garden. We're getting some new services added, and it looked like somebody touched the account. And the modem went back in, but I don't want those experiences. I want everything to work all the time. I don't even want to think about it. It's like any of those things, like your car. You don't want to think about your car. You just want to turn the key or push the button. The car starts and you go, right? So we want an enhanced quality experience where the customers are always happy with us. We want digital optics, digital return, link performance. All this becomes extremely consistent and predictable. Right now, you might think about, how often we have to troubleshoot the network. Is our network predictable? Do you know what the network's going to do tomorrow? And you're probably saying, well, I'm not quite sure what it's going to do. I think it's pretty predictable. With more fiber and more digital optics, the network is more reliable and more predictable. I know what the network's going to do. I know when the network's going to fail. And then this is the big one, spectrum allocation changes. You might have heard about mid-split and the term mid-split. So with Fiber Deep comes a lot of other pieces. Digital optics. You have to learn everything you can about digital optics and coherent optics. And spectrum changes. Yes, we're going to talk about mid-split because that's happening. That's going to happen. And with DOCSIS 3.1, 1.2, 1.7 gigahertz in the forward, I think 1.2 1.8 gigahertz is going to become the reality for a lot of operators that are looking for more 3.1, but definitely coming. Improved end-of-line performance. Why? We need OFDM, OFDMA. We need better signal to noise. We need higher order modulations. There's 4K QAM or 4096 QAM, right? We need better performance. There's no question about it. So better signal noise, better modulation error ratio, better bit error ratio, because we're removing noise from accumulating in the network. We're removing active devices, higher order modulations that I shared. The composite carrier to noise improves, and this is the same thing as is very similar to signal noise measurement, additive white Gaussian noise. But it's a basic noise model that has mimics the effect of random noise in the network, and also digital-like distortion. So Some folks might use, instead of signal to noise, a better way to characterize noise is CCN, right? But the clear thing here is fiber deep improves all these. So pre-BER, post-BER, maybe you use SWER, code word, error ratio. All these metrics are going to improve. You're not going to need as much power to go through the network. Fiber deep node splitting shrinks average cascade depths. So I can do more splitting of the nodes. So instead of just doing regular node splits, I can push those nodes much deeper in the network. And, I'm adding more nodes. As we saw that, Comcast is going to add a million nodes to their network. But that improves the service group sizes. If I could improve the service group sizes, I can improve the funnel effect. The funnel effect is all the noise coming back from the customer's homes that all combine into a service group and back to the head end. Well, if I have small service groups, there's less of that. There's more fiber, there's less noise. And then I talked about the launching point. You can launch into another architecture, whether that's the DAA, distributed access architecture I shared, fiber to the X, or XPON, EPON, GPON. So these are all nice things. So what does fiber deep look like? Well, the fiber deep stuff that in the access network, I kind of pulled those pieces together for you to kind of show you some pictures, the show and tell piece. But here's the multiplexing point. It could just be a fiber enclosure. And in the fiber enclosure, all you're doing is recovering those fibers. So what we do is we mux the fibers together at the head end, and then we demux them at the multiplexing point or mother node, depending on the device that you have, and then recover them, and then those fiber and wavelengths continue on to a fiber deep node. And basically what it looks like strand mounted. So you could be just using a regular multiplexing point. So you're like, oh, okay, I'm familiar with fiber enclosures. It's not a big deal. It could be a little bit more complex than that. So this is a example of a fiber deep node. And in the fiber deep node, this particular model here, the NC 4000, this particular model will support 1.2 gigahertz and 85 megahertz. And we'll talk about that. I can add an EDFA in there. The EDFA allows me to amplify optical signals and send them a longer distance. Here's an example of the MUX that would be used in one example that could be used in here. But here it's clear that here's our the node of the future, right? The fiber deep node. So that's what it looks like. Another example would be this. This is future architectures. Now the difference between this one and this one is this right here. So now I want to deliver PON and RFI and maybe CCAP kind of stuff out in the field. The OM6000, which I encourage you to visit ARIS's website. You can pull down spec sheets for the OM6000 and the NC 4000. And I just used ARIS as an example. But you can pull down the spec sheets, and I can drop in an RFI module in here. And that way I can do remote PHY, along with continue doing my fiber deep. And then if I want to also do XPON scenarios like EPON or GPON, right? It does a DWDM as well, so I can demux dense wave. And the difference is you might have heard of coarse wave. So there's wave division multiplexing, there's coarse wave that we use today in the HFC, and then there's dense wave. Dense wave is most attractive because I can have dense wave can go well beyond 32 wavelengths. So we can go up to, if we had to, 256 wavelengths. But that's kind of what it looks like as far as a node. A multiplexing point might look like this. It's just a node housing. And it could be just certain components of this. So depending on how you purchase this, you could have an OM6000, which is your multiplexing point that has an EDFA in it, and it has your DWDM. So you buy that chassis, right? And then you buy a more complex chassis for the fiber deep node, right? So you have different components for the fiber deep node, transmitter and receiver. You might also have RFI module in there as well, and then also support for EPON or GPON. So it depends on what components that you put inside, whether this is a multiplexing point or a fiber deep node. So this so you know that some operators are calling the multiplexing point a mother node, right? Because it feeds the child nodes or the fiber deep nodes. Okay. But let me just show it a different way too, just so we can make sure we understand this concept. 1.2, 85 megahertz, and RFI. Okay. So you can see spectrum changes are already happening. There's something called DOCSIS, symmetrical DOCSIS 3.1, which you can have the same upstream and downstream speeds. In order for that to happen, we're going to need to extend the upstream. Now, so you see, well, 85 megahertz, you know, how's that going to extend the upstream? That's hardly anything. Well, we could go to 204 megahertz. This OM 6000 supports that, but I can give you a whole nother presentation on why that doesn't work as well. Okay, and part of it is the equipment that's out in the field. Once we recover some of that equipment, then we can go to 204 megahertz. That's a whole nother talk. Well, maybe we'll do that another time. So here's what it looks like at the head end. I just simplified it. You have your transmitters 1 through 16. I just chose 16. You could do 32, 64. And we mux all those together, right? They go over your fiber out here to a demux location, your multiplexing point, and it could be an enclosure. It could be the mother node, depending on if you're going to drop an EDFA out in the field. This will need power. This will not. And then once you, at this point, you're at your multiplexing point, you're demuxing, then you're taking a wavelength and dropping it to a fiber deep node. Maybe it's 128 homes passed. Maybe it's 256 homes passed. Maybe it's 64. It's really what your scenario is for your network, right? What this gives us right out of the bat with fiber deep is now I can do individualized digital returns from each one of these fiber deep nodes. So I get a digital return. That's huge, because a digital return will provide a huge improvement in upstream signals, where it will allow me to start doing 256 QAM and start looking at 1024 QAM. But another advantage is for DOCSIS 3.1. How many of us have DOCSIS 3.1 upstreams? You think, well, not yet. We're working on it. And the reason for that is you need clean metrics for technologies like OFDMA, which is the upstream multiplexing for DOCSIS 3.1. And then here's another scenario, just showing you the EDFA in the field, right? Pretty much everything is the same, but so now this multiplexing point, we can't use the enclosure that we had here. We can't do that because we're going to supply power. We're going to take the EDFA and we're going to have that in there. Now this is just, all this is the symbol, the cable symbol for that, right? Everything else remains the same. Let's take another look at it. Now for the upstream return, this is, you know, this, I've just given some power levels, and notice the power levels are very, very low. But again, routed. You can route all your return via dense wave division multiplexing. So just another screenshot of the same thing, just trying to show you some scenarios. Let's get to this one. Here's your mother node. Okay, so this is your multiplexing point. Depending on the scenario, I need to go 40 kilometers, 25, 15, or 0 to 14. This is something you can calculate. This is an example. If I go a really long distance, then I can't do splits off it, because I'm not going to have enough power at the end of the line. Notice that -6 is my cutoff. So if I drop the distance from the mother node, and meaning if I did the 40 kilometers, I'm in a few hundred feet of the customer. If I did 25 kilometers, maybe I'm 500 feet of the customer, and 15 kilometers, I'm 1,000. But if I don't go as far, I can use an optical splitter, and then I can hit 2 fiber deep nodes. Maybe I only go 15 kilometers, I can hit 3 fiber deep nodes. Or less, I can do 4. So depending on the scenario, you don't need an entire fiber for every fiber deep node. So if you were thinking that, you were like, well, okay, I can use optical splitters. This is all going to come down from your design team. So this is your design team will say, okay, how many optical splitters can you use, and in what scenario? but you're able to do optical splits, and this is important information. Powering. You say, well, Steve, you got all these deep nodes. How does powering work? Let's take a look. So we know that there's no amplifiers, but it uses or mimics a centralized powering model. So we know it's not efficient to have power supplies at every pole, right? Or every fiber deep location. We can't do that. So what we're going to do is jump power for the nodes. Right? So what we can do is, here we have RF and AC coming out of our power supply. We have a line power inserter. We use a power feeder tie to another line power inserter, and then we can feed additional devices with power. At the tap, we throw a shunt in, and then we can just deliver RF off the tap. So this is an example of delivering power. Now, the fiber deep scenario does reduce power for operators, and some say as much as 50%. So you do save a lot of power, but you still need power for the optical nodes. So you don't save 100% of the power. So let's talk a little bit about the optics. I don't see any questions coming in. Feel free if you have any fiber deep questions, because along with the fiber deep, there's changes in the optics. So just jump in when you want. The bottleneck over our networks and the most costly to upgrade is the head end of the fiber node. Okay, and that's what we've been talking about. When we talk about an AM link, is actually analog intensity modulation, or AM modulation, and the performance of our optical network is determined by that. So we have solved, when you do fiber deep, you solve for the upstream, but we also have to solve for the downstream and make sure that we have digital and downstream as well. And since we're using IP is very bursty. Analog optics don't work very well. And as you want to put more IP on the network, we need to solve for that. And what we've been typically doing is, well, I'll just crank up the power for my analog so I can deliver all these services. And that's a short-term solution. Yeah, you can add more power, and that works. But using our fiber spectrum that's available, I have 4 analog carriers, so you can see them here, 1, 2, 3, 4. So I'm not really utilizing the space, my optical spectrum, as well as I should with analog optics, and that's what I'm getting at. So it's like, okay, digital optics. Okay, now these are non-coherent digital optics. So digital optics uses a technology called OOK, or on-off keying. It's like a flashlight, right? So if you took a flashlight, kept flickering and flickering and flickering it, and if you were fast enough, you could produce 10 gigs of light, right? Perhaps not. But the idea is that this will get you to 10 gigs. And people are like, yeah, good, I'm good. No, we're not good. 10 gigs is in the long-term solution for operators, it's not good. We want to go to terabits, 1 terabit. 1 terabit per second. But it definitely is a stepping stone. So if we can get to digital optics, absolutely. So digital in the forward path is definitely going to get us to a 10 gig. We could do high capacity with 10 different wavelengths to get 100 gig. Right? You can see the optical spectrum is utilized a heck of a lot better than we were using it in analog. We can improve the signal noise even further. So we were getting close to head-end hub in the fiber deep. We can now match the head-end and hub. Exactly. It's a non-coherent system because of the on-off piece, right? But it's a heck of a lot better than in analog optics. So I just wanted you to understand that we're replacing, when we do fiber deep, we have a digital return. And when we do fiber deep, we still have an analog forward, but we have the option to use digital optics in the forward by using technologies like remote PHY, right, with our fiber deep network. So now we have a pure digital optic network. Oh, good, we're happy. Not quite. Now the coherent optics, how about we do QPSK and QAM constellations over the optics instead of on-off keying? So on-off keying is 0, 1, 0, 1, but we know that in 256 QAM we can send 8 bits in a symbol. we know that when we go to 1024 QAM, we could do 10 bits per symbol. So why wouldn't I send more bits and instead of doing zeros and ones? So that's the idea with coherent optics. Just breaking it down for you, very simple. So when you hear coherent optics, and you can go to Cable Labs website, they have a project on coherent optics. They have a great article that I'm going to give credit to Cable Labs because I use a little bit of their article here. Read the article. It's very, very comprehensive, and it will kind of give you a full understanding of what's happening with the optics in the network when it comes to fiber deep. But the idea is you can do QAM constellations over fiber optics. And people might think, I thought we did that already. Not exactly. Today we do AM, amplitude modulation, to the node. At the node, then we recover to coax and RF signals, then we do QAM, right? And this is great for long-haul fiber optic networks, but we can use it for short haul, meaning we can use it for 80 kilometers. That's a short haul. You're like, well, I thought that was a long haul. And here's Cable Labs already has data to show that they could do 256 gigabits per second. Okay, we were just talking about 100. 256 gigabits per second over 80 kilometer link. Wow. And that's just the beginning, folks, because you can do 1,000 times. They're saying more than 1,000 times capacity what we have today. 1,000 times what we have today. So terabits per second. So just wanted to share that story. The other piece with fiber deep is the spectrum. So signals may operate differently. So here's what we have for return. We have 5 megahertz. Well, I don't know why I highlighted that. Let me get my little eraser out there. I didn't want to do that. I went too far. Go back to my ink color to 204. So there is the ability to go out to 204. So those products I was showing you for Mother Node and Fiber Deep Node, you can go out to 204. However, it's not ideal for our DCTs. It's not ideal for some of the set-top boxes. I could give you I did a whole presentation on this. So where the operators landed, they said, you know what, 85 megahertz, that is great. 85 megahertz acts and smells like 5 to 42. We know that Europe is doing 65, so there's no question 65 works. So if you used Eurodoxis, you've already been working with 65. But operators feel that 85, we can do it. And it doesn't require a huge overhaul of the network. And then we know in the downstream that 1218 is excellent as well. That's a good next step for us. Whether we get to 1.7, that in the spec 1.7 gigahertz, not so sure. But if we're at 1,002 megahertz today, getting to 1218 megahertz, we can do that. SCTE just came out with a operational practice on coexistence of MoCA with DOCSIS 3.1, because you might be thinking to yourself, well, Steve, then now you're in 1020, you're in the 1050 megahertz, which is now the MoCA realm, and we're going to have an issue. So there's a whole operational practice you can download from our website that talks about that. But clearly, we can extend the spectrum with fiber deep. And here's the mid split. Yes, there are high split options, and I kind of shared the story behind that. But the RF bandwidth there gives us about 80 megahertz. 80 megahertz. What can we do with 80 megahertz? Well, we can do this. We can put 12 of the 6.4 megahertz channels in that space. So whether that's for DOCSIS 3.0 deployments, you can support 8 channels with DOCSIS 3.0. Most people may not realize that. Whether we do that or not may make sense for some, may not make sense for others. Others might be looking at what can I do with 3.1, and I can utilize this a lot better with 3.1, right? So I could create 32 megahertz channels, 64 megahertz channels in this space. And for the downstream here, just kind of got a nice graphic here. So we go to 85 in the upstream. You're at a 750 or 860 today, But now look at this. You have this whole area of fiber deep that you can do. Right, so we have a whole extension that we can do all the way out to 1.2 gigahertz. What does this do for us? Symmetrical DOCSIS 3.1. Ideal for 3.1 because now we can do, if you're not familiar, DOCSIS 3.1 allows you to do 192 megahertz channels in the downstream. So think about, what could I do with that extra spectrum? I could perhaps do 292 megahertz channels. But in a 750 and an 860 megahertz system, I might only be able to run a single 24 megahertz DOCSIS 3.1 channel. And this is the transition point. I just wanted to kind of as I go to wrap things up here for us, just wanted to kind of show you the transition point to fiber to the home. In this scenario, you have your fiber deep node. There's my VHub, but we can see that both of these options are available. That I can still run my fiber deep network. I could still run an HFC, and I could still do VHub. I could do all three of these scenarios in my network. Total flexibility. I can have pockets of RFOG, pockets of EPON, just fiber deep, just HFC, and I could do DAA, distributed access architecture, all in the same network. So you're like, wow, I've been working on the HFC for quite some time. It's been the same everywhere I go, and now you're saying that it could change in certain pockets. Yes, because we need to have that flexibility when it comes to offering services. And as we you think about the cell towers that are going to be added to our network and the mobility and as 5G makes its way into the network, and operators, it's clear. If you look at Liberty Global, and Mike Fries gave a great presentation at Expo, and you can look him up. That's Fries. He is the CEO of Liberty Global, and it's clear that Liberty Global and mobility and cable is one in Europe. It's only a matter of time before it comes here, and we're already seeing it. With that mobility, this fiber deep network gives us flexibility to be ready for that next service, right? So some of the challenges, I just had a few challenges that I listed here. More fiber means more optical connections, multiple wavelengths, and new signal behaviors. SCTE, if you're not aware, we developed a 3D cable world. So our training today, you can go in and go in this 3D cable world, and you can practice all types of fiber activities. And that means that when you're taking our courses, you come out of our ebooks, you can actually go in and practice. And I was given some of the scenarios. If we're looking at building an exercise in that world where you put on optical connectors, and if you do that manually, techs might take 5 to 10 times to put an optical connector on until they feel comfortable, right? But if you do it in a virtual world, then it saves a ton of money because optical connectors are expensive. But the key thing is there's going to be a lot of optical connections, many more wavelengths. So if you're not very familiar with RF, you need to learn more RF because optics is terahertz in RF. There's going to be new signal behaviors that you're not used to, absorption and scattering and relay scattering and all these different things, micro bends, macro bends that you need to be, you need to catch up on. We have a great course that gets you up to speed. So you have to be tooled, right? Hey, I know how to use an optical power meter. That's great because we're using PON power meters today. So if you know how to use an optical power meter, well, how to use a PON power meter? And if you know how to use an OTDR, that's great. And if you don't, well, you need to learn that. And then you need to learn how to use them in an optical distribution network, which is what's replacing the HFC, and how OTDR operates through optical splitters, right? So there's new tools, new ways to use the tools. There's new measurements, new ways to characterize the network. There's complexity, as you saw. Hopefully I wasn't too complex. I tried to make it simple and break it down for you. New troubleshooting methods, obviously contamination now. You have to worry about contaminating the fiber, which, a speck of dust on an RF connector, no big deal. A speck of dust on an optical connector, you could knock out half the neighborhood. So it's a different world. And new protocols. You're like, I've been working with DOCSIS and perhaps I work with MPEG for video. But now I got to deal with Ethernet, and now IP's coming, and then there's the next version of IP, version 6. So there's different things to think about. And I just have over here just a picture of ribbon fiber. Again, it is new stuff, new thinking. Like, well, what's ribbon fiber? And in this particular example, this splice shows that half the ribbon fiber is dirty. So just the way you splice and prepare fiber, cleave and clean, all these things are changing. So in summary, the fiber deep design supports future advanced technologies. I shared all those different technologies. The big thing for MSOs, fiber deep, the velocity of technology and platform deployments are changing. So there's flexibility there. We can expand downstream, upstream. We can increase digital optics. We can leverage emerging technologies like distributed access architectures. And then I just wanted to share, how do you prepare for all this? Like Steve just gave us a huge amount of material. What do I do now? We have folks, one of our most popular boot camps to date has been this one. And actually probably in the history of SCTE, our most popular by far, most number of students went through, is an on-site boot camp on fiber to the X and fiber deep for engineers. But you're like, I don't have time to go to a boot camp. We have an online course, fiber to the X today. We're putting out one with fiber deep by the end of the year. So you get the fiber deep pieces. You can learn all about broadband fiber distribution and installation. The nice thing, any course that you get through SCTE, you get access for 3 years. So if you purchase the course I just shared with you, you get access for that for 3 years. And every update that goes along with it. Our new system, the way it works, my team pushes out thousands of updates in our classes, and you get every one of them. So if you buy a class, you have it for 3 years, and you can reference it on our app. That means if you're in the field, you can look things up. We have a fundamentals of optical fiber. Maybe you're just getting started. We actually delivered a boot camp 2 weeks ago for folks trying to get up to speed with that. We do have the fiber maintenance technician course online. That's a hard one. That's a challenging one because there's a lot of fiber stuff in there. And then we're working on a brand new broadband fiber distribution and installation certification. So this is for folks that are supporting the fiber cabinets, that are supporting the mother nodes, that are supporting the fiber deep nodes, supporting the fiber to the X at the side of the house, EPONs, GPONs, all those pieces. So that's coming soon. Brand new certification for you. And you say, well, all right, Steve, I don't have time. I don't have the money right now to take a class. Sounds great. We do have a foundation you can take advantage of. So if you're an SCT member, go to the foundation. There's lots of money sitting there to take classes. If you have a membership, I just pulled out a few of the webinars that we have on our website. So you want to learn about optical networks? No problem. We got it. Fiber deep, got it. RFOG, fiber optic splicing. You want to learn a little bit about DOCSIS 3.1, maybe some remote PHY. We have all these webinars on our website. So you can start consuming content today with your membership. And here's just, I know it's small, but I took a screenshot this morning of our chapter webinars. And there was one, the latest one, November 7th, all things fiber. All things fiber. There's a link right here you've probably been seeing through the show this morning that if you go here, it'll tell you all about our Fiber to the X program, all the training. There's on a really comprehensive page that our marketing team put together that you want to check out. Okay. With that, unfortunately, my time is, I don't want to talk all day. I probably could, but I'll stop here for questions, thoughts, cheap shots, anything you have. Here's my email. If you want to get in touch with me and ask me some questions that way, that's fine. So what kind of questions can I answer? Anybody still there? Great presentation. Thank you, Scott. I'm glad you enjoyed the presentation. I hope, I know it was a lot. I hope it wasn't too much for the audience. Scott, how many people do we have in the audience? Oh, you can't see that from there. Okay. Okay. Thank you, Sean. So no questions I can answer. Well, that's okay. It probably was a lot of information. I hope I didn't go overboard with you, but I wanted to. When you asked me to speak about Fiber Deep, I really wanted to share the whole entire story instead of giving you a piece of it. I kind of looked out what some other folks did with Fiber Deep, and it's fine. You just focus on the Fiber Deep side, but it's really part of a greater strategy. I was with some of the top leaders yesterday at Comcast, and I sit with some of the top leaders at Charter. This is just Fiber Deep is just one of those pieces in this greater strategy for operators moving into the next 5-10 years. And I wanted to kind of share that whole story with you because Fiber Deep really itself is not very complex. There's not a lot of pieces to it. It's all the other pieces added on the Fiber Deep that makes it complex. Okay. Oh, you're welcome, Lawrence. Hey, how you doing, Larry? I didn't mean to say Lawrence. I'm reading. How you doing, Larry? Well, thank you. I'm glad you enjoyed the presentation. Please reach out if you have any questions at all. And thank you for your time. Everybody have a great day. And Jessica, I send it back to you.
Jessica, are you on?
Yep, you should have everything back, Sean.
Okay, so I'm going to just stop recording at this point.